Okay, so moving on to the third problem, we have here the aluminum bar. So it is overhung and it is 10 mm short to touch this wall here. So there is a 10 mm clearance here. And then we are going to calculate a temperature at which the compressive stress in the bar will be 20 megapascal. So we would like to reiterate here that if we need to stretch or elongate this through the temperature, we just have to increase the temperature, because a certain increase would mean an elongation and a decrease or cool down would mean a contraction of the member. So that is a natural residual effect on the material with regards to the temperature. So in this case, if this bar would be allowed to stretch due to temperature, okay, so if I am going to have a stretch here due to temperature, a stretch would have to we would have to increase the temperature. Okay, so let us increase this temperature. So if I'm going to increase the temperature so that this material would just feel the 10 mm clearance here, there will be no compressive stress yet because there is no push on this material. Okay, so it is just stretch because of the increase in temperature. So if we wanted to have a stress, of course we will increase the temperature. Okay, we will further increase the temperature so that it will exceed the 10 mm gap here. So let us have that to be illustrated. I will further add a temperature so that this will extend on the wall. Okay, so this will be now labeled, okay, as delta due to temperature. Say this is delta due to temperature. Say this is delta due to temperature. So beyond this 10 millimeter gap, the material will begin to be pushed, di ba? Mapupush na yan kapag lumampas siya dito sa gap na to. So once this will exceed to that line, it will begin to have a compressive stress. So I'll just shade this portion. So this shaded portion here is the portion where there is already a stress in the material. Okay, so kapag pinahaba mo pa ng lalo yan, hahaba pa yan, yung delta T mo, it will further elongate, and then there will be also an increase in the deformation. Okay, and there will be an increase in the deformation due to temperature. Of course, it follows that this delta here will have a corresponding increase. Okay, kapag humaba yung delta T, hahaba rin yung delta P. And as delta P will elongate further, okay, tataas yung ating stress, or the stress due to compression or compressive stress will eventually increase. Okay, so our task is just that the delta P eksaktong 20 megapascal. Okay, the delta P will have an induced stress of exactly 20 megapascal. So that is the question. So the question is what will be that final temperature? Okay. So that we will be having a stress in the bar in compression equivalent to 20 megapascal. So again, kapag hindi pa na-touch tong wall, there will be no compressive stress. Ang stress lang na meron is temperature due to or thermal stress. Okay? So within the gap of 10 millimeter, but beyond this gap, it will begin to have a compressive stress. So looking at the geometry, we can form now the equation. Okay, so we can just say that delta T is equal to 10 plus delta due to push. Okay, so we simply substitute the formula for delta due to temperature, that is alpha L delta T. Okay, this is equal to 10 plus, I'll just have to express this in terms of the stress, sigma L all over E. So of course, we all know na nanggaling yan dito, PL over AE. So just merge this into sigma. Okay, so with this, we'll just substitute the given here. So the alpha for aluminum bar is 24 times 10 raised to negative 6. And the original length is, we have here 4 meters, or that is 4,000 in terms of millimeters. Then just copy 10 here and then expand this. We have to solve for the area. So this is 20 and then the length is 4,000. All over E. By the way, kulang pala to ng delta T. So it should contain here a delta T. So this is alpha, this is L, and we should place here our unknown delta T. So by and by we will expand this. So delta T is actually the final temperature, which is the unknown, less the initial temperature. So I think it is set to be negative 15 degrees. So of course, this negative indicates a freezing temperature. Okay, so you must have to carry that negative sign into the equation. So we just copy 4,000 is equal to 10 plus 20 times 4,000. We have a rigidity or elasticity, modulus of elasticity of 69,000 megapascals. So as we can see, in the unknown, there is a single unknown, which is the final temperature. So this is equal to 101.24 degrees Celsius. Okay, so this is for the third problem. So next problem, we have problem number 4. So in this problem, we have an outer bronze here that is 25 millimeter thick. So the diameter of that is 500 millimeter. So it snugly fits over an inner hoop 15 millimeter thick. Both hoops has a length of 350 millimeters. Calculate the contact pressure between the hoops if there will be a cool down of temperature from 120 degrees to 30 degrees Celsius. Neglect the buckling effect of the two hoops and assume the coefficient of expansion for bronze and steel. So these are the values, 19 and 11.7. And the modulus of elasticity as well are given for the two material. So as we can see, if the bronze hoop and steel hoop snugly fits together on this system, once there will be a stretch or a compression, okay, once there will be a contraction on the material, there will be a pressure, contact pressure between these two hoops. Okay, so if we investigate the coefficient of thermal expansion, the thermal expansion for bronze is greater than that of steel. So let us write that one. Comparison. For alpha, we have the bronze to be 19 times 10 raised to negative 6. And then for the steel, we have 11.7 times 10 raised to negative 6. So what is the meaning of this one if we are going to compare it? So a certain temperature, the bronze will have a larger effect or larger deformation per degree Celsius. Okay, so if we have a an increase in temperature, it will expand longer than steel. And if we have a cool down temperature or a decrease in temperature, there will be lesser length or a larger length will be contracted compared to steel material. So, ibig sabihin, yung bronze, mas mahaba ang ihahaba kapag humaba. At kapag umikli, mas maikli ang iikli kapag umikli versus that of the steel material. So that is the effect of this alpha or the coefficient of thermal expansion. So going back to this setup, kapag nag-contract yan, mas magko-contract yung bronze hoop. And what will be the effect of that? So there will be now a resistance between the two. And the resistance is because of the pressure. Kasi ganito yan. So kung ito yung ating bronze hoop and this is the steel hoop, pag umikli itong bronze hoop, okay, halimbawa pag umikli ito, iikli nga yan, pero mas iikli yung nasa labas, okay? The outer hoop will have more contraction than that of the inner hoop here. So therefore there will be a pressure that will be developed here. So actually I have placed here a figure so that you can see. Okay, so the pressure is expressed in PA. Okay, why? Because there will be a contact pressure between these two hoops. Okay, so remember pressure, the pressure is similar to your formula in stress, ano? Yung stress kasi internal yon, internal pressure. Okay, and the contact pressure is an external pressure between two contact surfaces. So when that happens, generally ang ating formula sa pressure is equal to force all over area. So remember this formula, it is also the formula for the stress, diba? Sigma is equal to P over A or force all over area. So it is similar. As I have said, yung stress sa internal yon. So, kapag pressure, this is an external effect. That is why, kapag pressured ka, di ba? Saan nanggagaling yung yung pressure? Sa trabaho mo or sa love life mo, di ba? So, if that happens, that is external, So, anong mangyayari sa internal mo or sa kaloob-looban mo? Of course, you will be stressed. Okay? Similarly, ganito rin yon. Yung effect ng external forces will cause an internal effect that is stress. And both are in terms of Pascal. Kapag sinabi kasi nating Pascal, yung Pascal, yan yung legacy ni pressure. Okay? The legacy of Pascal is on pressure. That is why it is termed as Pascal. Yung external kasi, kukunti lang yan. Pero yung effect ng internal pressure or the stress is expressed into a more larger unit. Remember that the gap of kilopascal and megapascal is 1,000. Okay, going back to this, there will be now a rectangular area here. Okay, so yung rectangular shape na yan, yun yung tinatawag na pressure. So, pressure is equal to force all over area. So, therefore, we are going to express that pressure is equal to force all over area. So, kung titignan natin dito, ano ba yung force due to pressure? Ito, FP. So, force due to pressure can be derived if we multiply the external pressure times the surface area. Ibig sabihin lang kasi niyan, kung ito yung ating surface and then subjected to a certain pressure, no? May pressure yan. So, meaning, lahat nitong point load na ito is distributed all over the area, no? Kaya nga, yung Newton is being divided by square meter, or this is force all over area. So, ngayon, if you wanted to have the overall effect of it in terms of a certain force, so this is force due to pressure, this is expressed in Newton. Okay? How will you make this pressure in terms of a force? That is the question. Of course, you'll just have to multiply it by the square meter. Okay? So that this will cancel, and then you come up with a concentrated load that is pointed on the center of gravity of the surface. Okay? So, ganun din yung sa internal, So, as we can see here, sa internal naman, the external force will be countered by the external one. Okay? So, anong magiging reaction ng bronze dito? Because bronze is the outer material, the bronze will directly be stretched, di ba? Kasi nga, this is a push against the bronze hoop, and the effect of it, stress or tensile stress. Okay? Okay, further, this contact shows dito sa baba on the lower drawing here, there will be a resistance on the inner hoop. Kung may resistance sa inner hoop, of course, ito yung inner hoop, kinakain ng, or it is being compressed by this outer hoop. Anong magiging reaction nito, inner hoop? It will be a compression. Okay? So, the effect, kaya nga, kinocompress nga nito, okay? Kapag kinocompress nito, at the same time, this is being stretched because there is a resistance on this inner hoop. Okay? That is why, as you can see, the internal effect on this cross-sectional area, no? Ito yung cross-sectional area ng internal hoop. that will be a compressive type of resistance. And for the stretch, ito nga yung umiipit, kaya humahaba siya. Pinipigilan yung kanyang pag-stretch. Or pinipigilan yung kanyang contraction. Kapag pinigilan yung contraction, that is basically a tensile effect. Okay. So finally, going back to this, we are tasked to compute for this. Force due to pressure as well as the pressure. Okay, so what is the pressure developed between these two hoops? So that is the question. So actually, with this illustration, we can now tell or formulate an equation relating to that one. We can just say that by summation forces vertical, so if we wanted to project it in a horizontal manner, ito yun. Okay, there will be a pressure due to contact. Okay, so this pressure due to contact can be expressed into a single concentrated load. This is force due to pressure, and then this force due to pressure, of course, will be resisted by two tensile load in the bronze. So this is PB. Okay, PB. So out of this, we can see that summation forces along the vertical axis, this is equal to 0. So an equilibrium would be F due to pressure will be equal to 2 P of bronze. And remember that force due to pressure from the formula here is just equal to pressure times area. Okay, pressure times area, and then just copy that, and basically this will now be our working equation to solve for the unknown pressure here. So let this be our first equation. All we need is to determine the pressure or the force on the bronze rod or on the outer hoop. Where shall we get that? We are going to solve for the forces out of the deformation equation. So I will now unfold the hoops. Okay, let us unfold the hoops. So unfolding the hoops, we will be having here a rectangular section. Okay, say this is the rectangular section for bronze. Okay, and then of course we have here the inner one, steel. Okay, of course steel is shorter than that of bronze. Okay, a little bit shorter than that of bronze. So basically this dimension is what? The perimeter of the circle, right? This is the perimeter of the circle, or this is 2 pi r. So anyway, this does not matter, no? Does not matter what is this length. I'll just wanted to show that this is the unfolded circular or cylinder. Unfolded cylinder will yield to a rectangular section. So after unfolding, let us have a scenario. I'll just put a line here. So this line is a line where there is still no temperature change. So ngayon, if there is a cooling down, this will contract, right? It will contract. So, for the bronze, so sa bronze muna, ito yung contraction niya. Mas mahaba yung i-contract niya. So, this line is for bronze. And then, another line will be for steel. Therefore, kung titignan natin, mas mahaba ang ihahaba ng bronze. Okay? This is delta due to temperature of bronze. Okay? And for the steel, this one. Delta due to temperature of the steel. Okay? So as I have said, the contraction is more on bronze compared to steel. That is why if you notice, mas maikli yung inikli ng bronze compared to steel. So therefore, this shall be labeled as the corresponding delta for those material. So of course, because of resistance, sabi ko nga iniipit yung steel, pinipigilan ng steel yung paghaba ng bronze, there will be now a stretch on the bronze rod. Okay? So what is the stress all about? So here I'm going to draw a line boundary beyond the steel. So if this is the boundary, we are going to label this as boundary resistance between the bronze and steel. Why boundary? In the first place, itong bronze na to, hindi matutodo na humaba on this length. Why? Because pinipigilan nga ng steel. Okay? Pinipigilan ng steel. At the same time, yung steel, nag-contract na nga yung steel. Madadagdagan pa yung pag-contract niya kasi iniipit ng outer hoop. So, what is the effect on the bronze rod? So, hindi ito mapu-full dito kasi nga pinipigilan ng steel. Meaning, within the boundary resistance, no? Itong portion na to is subjected to stress due to force. Okay? Or tensile stress yan. So, I'll just label that as delta of bronze. Okay? And then, for the steel, this shaded portion here is delta steel. Okay? Why delta steel? This is a compression. No? So, aside from the contraction due to steel, madadagdagan pa yung contraction niya. Kasi nga, iniipit ng outer. Yun. Madadagdagan ng compressive stress. So, the shortening will be composed of the compression due to the resistance, okay, and due to shortening of the bronze. Ngayon, yung bronze, pinipigilan, there's a resistance in steel. That is why this is a stretch or the tensile stress. Okay. So as we can see now, we have established the geometry of the deformation wherein there will be a tensile effect on bronze and a compressive effect on the steel. So by that, we can now write the equation out of this. On the left portion, we just add that one. What will be the relationship? Delta temperature, or due to temperature of bronze, okay, this one, okay, is equal to this one, delta of bronze due to tension, right? And then plus delta of steel due to compressive force caused by the bronze, and then plus delta due to temperature of the steel. Okay, so this is now the working equation to solve for the PB, because PB here is the key. Okay, PB here is the key to the solution. So let us further expand this into its formula. Alpha L delta T of the bronze, okay, and then this is PL. Sige, I'll just have this PB LB over area of bronze. This is E of bronze plus delta steel. This is P of steel, length of steel, the area of steel, and then of course the elasticity for steel, and then this is plus alpha L delta T of the steel. Okay, expanding it further, the alpha, or the coefficient of thermal expansion for the bronze, is given, okay, ilan yun? We have, so I'll just carry this one. We have 19 times 10 raised to negative 6. Okay. 19 times 10 raised to negative 6. And then for the length, what is the length to be considered here? So if you would notice, L here is common to all of the equation. Okay, the lengths are the same, di ba? So that length is this 350 millimeter. That is common to all of the sides of the equation. And then delta T, the final temperature, is equal to how much? 120 to 30 degrees Celsius. So 120 minus 30. Okay, so next, this is equal to PB we do not know that variable yet, and then area of the bronze. Okay, so what is the area of the bronze to be considered here? So if we have this one, the area is actually this red shaded portion here for bronze. And what is that red portion there? It is 350. Okay, so 350 by the thickness, right? And the thickness is 25 millimeter. Okay, so we have a thickness of 25 millimeter. Okay, so 25 by 350 is being stretched. 25 by 350 is being stretched. So that is the area that is being stretched. And then E here for bronze is 83,000. Okay. And then plus PS all over. So ano naman yung na-compress sa steel? What cross-sectional areas being compressed? So as we can see here in the figure again, yung green shaded portion is the fiber that is being compressed. So that is why that is 350 by the thickness of the hoop, that is 15 millimeter. 350 by 15. So we have 15 by 350, and this is 200,000 megapascals. And then we add again the alpha, which is 11.7 times 10 raised to negative 6, and the length is already cancelled. Delta T here is 120. 120 minus 30. So here is, as we can see, we have two unknowns for this equation. So all we need is to relate the relationship between the P of bronze and the P of steel by simplifying this equation. So before we do that, of course, we need another equation so that we can express PB in terms of PS. So recalling our first equation, we have a PB here contained in the equation. However, it does not express any relationship to PS. So where shall we get that one? We are going to relate the two hoops. Okay, this is the inner hoop and this is the outer hoop. This is the outer hoop, this is the inner hoop. This is a stretch. Okay, so this is P of bronze, and this is P of steel. Of course, by that, we can conclude that the force due to bronze is equal to the force on the steel. So they are just equal. Okay, so with that to be equal, we'll just have to replace one of them. Okay, and then come up with the P of bronze. Anyway, P of bronze is our concern here, aside from the P of steel. So we prioritize solving for P of bronze by replacing the PS in terms of P of bronze. Okay, so solving for P of bronze, we have here the simplification. And then for the last term, we have 1.053 times 10 raised to negative 3. By the way, we have here also times PB. So this term will add, and this shall be transposed here and will combine to this, or will subtract to this. Okay, so by that we have PB. We have 284,237.73. So this is in Newton. Okay, so this is also equal to the P of steel. So finally, going back to our first equation, okay, the pressure is unknown here. And what is the area? The area is 350 by 500. Okay, so 350 by 500, or the shaded portion here, 350 by 500. Okay, this is equal to 2 times PB, which is that 284,237.73. Okay, so finally the pressure is equal to 3.25 megapascals. So this is the answer. So with this, I hope you absorb that video on this particular problem. So next time we will have more examples. So I think it is your duty now to practice problems. Perhaps you can resolve all what we have discussed on thermal stress. Resolve it at your own without looking at any notes, so that you can also gauge your skills and try another problem that coming from the references given to you. So thank you for this attending this video lecture. So see you on the next video.